everyone, welcome to Unfog with Dr. Athar Parveen, and today we are going to discuss the chemistry question paper of Hstr examination of year 2015. We will also highlight those chapters from which more number of questions have been asked and those chapters from which the questions may be asked in Hstr exam of 2022. So, let's begin with our class. Before I start discussing the paper, I request you all that before seeing the answers of the questions, please pause the video and try to solve the question by your own. If you're not able to solve it, even after trying many times, then don't worry. You can play the video and learn the answer. So, let's see the first question. The first question says, among the following compounds, the bond length between the carbon atom is the shortest in, and the options are ethane, ethyne, ethyne and benzene. What we have to do here is first find the bond order of the given compounds. So what is bond order? Let's write the bond order as BO. Okay. So what is bond order? Bond order is nothing but the number of bonds between two carbon atoms. Okay, number of bonds. So that will be the bond order. Now let's take a look at our options. We have ethane. Ethane is an alkane, right? So it will have a single bond between two carbon atoms. So its bond order becomes 1. Next we have ethene, right? Ethene has a double bond between two carbon atoms. So its bond order becomes 2. Then we have ethyne. Ethyne is alkyne. Therefore, the bond order will be 3 because it has triple bond between two carbon atoms, right? Next we have is benzene. So benzene structure looks like this, right? It has alternating single bonds and double bonds. Alternating sigma bond. Single bond is known as sigma bonds and double bond or a triple bond, they are known as pi bonds. Okay, so it has alternating sigma bond and pi bond. Now after calculating the number of bonding electrons and the number of anti-bonding electrons present in benzene, the bond order comes as 1.5. Now we have the bond order here, but the question is asking what is the bond length, right? The shortest bond length. So the relation between bond order and bond length is bond order is inversely proportional to the bond length of the carbon atoms. Okay. So bond order is inversely proportional to the bond length. So he is asking for the shortest bond length, right? So shortest bond length means I should find a compound which has the highest bond order. Okay, so let's see the bond orders. We have bond order 1, 2, 3 and 1.5. So the highest bond order here is 3 and that is for ethyne. So ethyne is the answer. Ethyne will have the shortest bond length between two carbon atoms. It is ethyne, right? So ethyne is written as this. This is ethyne. So ethyne will have the shortest bond length between its two carbon atoms. The next question asks, the law which describes the relationship between the volume and temperature of a gas at constant pressure is called, and the options are given as Boyle's law, Charles' law, Dalton's law and Avogadro's law. So let's see these laws first. So we have Boyle's law, right? The Boyle's law gives us the relationship between the pressure and temperature of the gas. According to this, pressure is inversely proportional to the temperature. Okay, but we don't have the volume constant here. So Boyle's law cannot be the answer. Then next we have is Charles' law. Okay, so Charles' law gives us a relationship between the volume and temperature of the gas. According to Charles' law, volume is directly proportional to temperature. So we have volume also, temperature also. So the correct option should be second option, Charles' law. The third option, Dalton's law, and fourth option, Avogadro's law, cannot be the answer, because what Dalton's law says is it gave us a law known as Dalton's law of partial pressure. Okay, so what this Dalton's law of partial pressure says is that, for example, you have a mixture of gases. Okay, so what will be the pressure exerted by these mixture of gases will be equal to the pressure exerted by those individual gases, like pressure exerted by the first gas, pressure exerted by the second gas, with pressure exerted by the third gas, and so on. If you add all of those pressures, then that resultant will be the pressure exerted by that mixture of gas. So we don't have volume and temperature here, right? So Dalton's law cannot be the answer. Next we have is Avogadro's law. So Avogadro's law actually gives us the relationship between the volume and the number of moles of the gas. According to Avogadro's law, volume is directly proportional to N. That is the mole of the gases, number of moles in the gas. Again, we don't have temperature here, right? So Avogadro's law cannot be the answer. So the correct answer for our second question should be Charles' law, because it gives relation between volume and temperature. The third question says the oxidation number of chromium in K2Cr2O7 is. So K2Cr2O7 is also known as potassium dichromate. Let's not look at the options here. Okay, the options here are numbers. The numbers will only confuse us. Now let's try to solve the answer by ourselves. Okay, now let's write down K2Cr2O7, potassium dichromate. Now we have to find the oxidation number of chromium here. Okay, so let's take chromium as X. But here two atoms of chromium are present, right? So we'll take it as 2X. Now we know the oxidation number of potassium. It is +1. And oxidation number of oxygen is -2. So what we'll do is we'll make an equation out of this. So we'll write it as 2X for chromium, which we have to find, plus +1 of potassium into 2, because there are 2 atoms of potassium present here, into 2, plus the same way we'll do for oxygen. There are 7 atoms of oxygen, right? But the oxidation state is -2. So we'll do it as -2 into 7. Now if you look at this compound, there is no charge on this compound, right? Here in the question, no charge on this compound is given, which means it is a neutral compound. So I will make this equal to 0. For example, if there was a charge, in case there was a charge on this compound, then I would write that charge instead of this 0. Now let's solve this equation. So after solving, we get as -14 equals to 0. Then we have x equals to 12 by 2, which on cancellation gives +6. So here the oxidation number of chromium is +6. Is there +6 here? Yes, option number 3. So option number 3 is the right answer. Now the fourth question says, identify the exothermic process among the following. Then first option we have is melting of solid, evaporation of liquid, sublimation of solid, and combustion of solid. So what does exothermic process mean? So exothermic process means that there is energy or heat being released from that action. That process is releasing heat and energy into its environment. Okay. So the first option says melting of solid, right? So melting of solid, let's take ice cube as an example. Okay. If we keep an ice cube on the table at room temperature, then this ice cube will start melting, right? It will start becoming slowly, it will start becoming water. So this change from ice to water is because it is absorbing heat. It is absorbing heat from its surroundings. So it is taking in the heat, right? So that becomes an endothermic process. So melting of solid is not the answer. Then we have evaporation of liquid. Now take this water only, that ice cube's water. You know? Now this ice cube water will again absorb heat in order to become water vapor. It will evaporate, right? So again it is taking inside the heat from its surrounding. So this again becomes the endothermic process. Now evaporation of liquid is also not the answer. Then we have the sublimation of solid, right? Sublimation of solid, let's take naphthalene balls. The naphthalene balls, they change their state from solid to gaseous, right? Directly. And this also happens by the absorption of heat. Again, this becomes the endothermic process. So it is not the answer. These three, melting of solid, evaporation of liquid, and sublimation of solids, these three are examples of endothermic process because they all happen by the absorption of heat. Okay. Now last option should be the correct answer. But why? It is saying combustion of solid. So combustion of solid means burning of solid. Okay. Now let's take firewood as an example. So there is firewood burning. Now firewood is hot, right? We feel very warm when we are sitting around the firewood, right? It is very warm and very calming. But why is this warmth? Why are we feeling this warmth? Because it is releasing heat into its surrounding. So releasing heat means it becomes an exothermic process. So the answer is option number 4. Combustion of solid. So the next fifth question we have is, ethyne is prepared by the action of water on. And first option we have is Al4C3, CaC2, CaCO3 and CH3COO whole taken twice with Ca. Now we are reacting water with a compound named calcium carbide or CaC2, which on reaction they will give us ethyne, which is CH triple bond CH plus calcium hydroxide, CaOH taken twice, which is calcium hydroxide. So this is one of the basic preparation methods of ethyne, which should be remembered by you. Okay. So calcium carbide CaC2. Fifth question ka answer is the second option, CaC2, calcium carbide. You need to remember this reaction. The sixth question is asking, benzene does not undergo addition reaction easily because. So now first let us how the benzene structure looks like. It has alternating single bond and double bond, right? It has alternating sigma bond and an alternating pi bonds here, right? We have sigma bond again here and then again we have alternating pi bond. Now here the pi bond will have pi electrons, right? So these pi electrons are delocalized within the structure. Delocalized means they are always present within the structure. So because of this, there is a very good stability present in the benzene structure. So this stability is called as resonance stability. Okay. Now, all the compounds, any compound, whatever compound or element it is, they always try to be in their stable state. Okay. Now here it is having a very good stability, right? Because of the delocalization of its pi electrons. Now it will not undergo addition reaction, because it will, if it undergoes addition reaction, the stability of the compound will be lost. Okay. So is there any option matching? It has a cyclic structure, double bonds in it are very strong, resonance stabilized system is to be preserved, it has 6 hydrogen atoms. So here the correct option is resonance stabilized system is to be preserved. Okay. Now the 7th question. If 2 grams of urea is dissolved in 38 grams of water, then the percentage of urea by mass in the solution is. So again, let's not look at the options. They'll only confuse us. Let's solve it by our own. So what we have here? We have urea. It is given as 2 grams in the question. Then we have water, which is H2O. It is given as 38 grams, right? So the total mass of the solution will be, total mass of solution will be 2 plus 38, right? It will be 40 grams. But what is the question asking? It wants the percentage of urea by mass in the solution. So, percentage of urea by mass will be equal to, how much of urea is given? 2 grams of urea is given, right? 2. But what is the mass of the solution? It is 40 grams. So, divided by 40. But it is asking in percentage, right? So, into 100 we should do. Now, after cancellation, 0, 0 cancel, 2 ones are 2 twos are, and then 2 fives are. So, the answer should be 5%. Is there 5% as an answer? Yes. First option is the right answer. The next question, 8th question we have is, the zigzag motion of colloidal particles was first observed by option 1 John Tyndall, option 2 Robert Brown, option 3 Sycamore, and option 4 Ostwald. So the correct option is Robert Brown. It was scientist Robert Brown who discovered this zigzag motion of colloidal particles first. So the next 9th question we have is, an example of covalent crystalline solid is silicon oxide, calcium fluoride, sodium chloride, and this organic compound. This is an organic compound, but it is for naphthalene. It is the chemical formula for naphthalene. Okay. Now, if we look at the first option, silicon oxide, here the silicon and oxygen atoms, they have a covalent bond between them, and they also have a crystalline structure. So they are covalent, they are crystal also. So the correct answer is silicon oxide. But these three cannot be the right answer, because in calcium fluoride, the calcium and fluorine ions, they share an ionic bond. Okay, so in the first condition itself, they are wrong. Okay, now here in sodium chloride, in sodium and chlorine ions, they share an ionic bonding. Again, for first condition, they are wrong. But here in naphthalene, naphthalene is an organic compound, right? In organic compounds, They don't have any ionic or covalent bonding. They have a weak van der Waals force. Okay, so this weak van der Waals force of attraction makes a molecular bond. So this molecular bond exists between the atoms of the organic compound. So with they don't have ionic bonding, covalent bonding. So again for first condition, they cannot be the right answer. So the next three options are not the right answer. The correct option is silicon oxide. The next 10th question is, colligative properties of the solutions are those which depend upon. The first option is nature of the solvent, nature of the solute, the number of solvent molecules, and the number of solute particles. Actually, the colligative properties are those which depend upon the number of the solute particles. So, fourth option is the correct answer. It does not depend upon the nature of the solvent, the nature of the solute, or the nature of the solvent molecules. It only depends upon the number of solute particles. Now, 11th question. Now, 11th question is asking, in a H2O2 fuel cell, the reaction occurring at the cathode is. So, actually in H2O2 fuel cell, the reaction occurring at anode can be written as H2 plus 2OH minus gives 2H2O plus 2 electrons. And the reaction occurring at cathode can be written as O2 plus 2H2O plus 4 electrons gives 4OH minus. But he is asking for the reaction occurring at cathode. So we have anyone which is matching with this equation. We have O2 plus 2H2O plus 4 electrons. Third option. So the third option is the right answer. Now the 12th question asks, which among the following is a thermosetting plastic? Please keep in mind the word setting, okay? So it is asking which of the following is a thermosetting plastic. So first option we have polypropylene, polystyrene, melamine and polyethylene. So thermosetting plastics, actually it is melamine, option 3. The rest of these three options are actually only thermoplastics. Okay, they are not thermosetting plastics, they are only thermoplastics. The next question we have is, the electronic configuration of the sodium ion is. Now keep in mind they are asking for sodium ion, Na1+, not the usual sodium that we write for. Okay. Now if you write down the electronic configuration for sodium, it is as 1s2, 2s2, 2p6 and 3s1. Sodium is actually an alkali metal, right? An alkali metal outer electronic configuration is NS1. So NS1 means here 3s1 is here. So NS1 electronic configuration, from that you can identify sodium electronic configuration. But here he is asking for sodium ions electronic configuration. So sodium, it is a metal, right? So being a metal, it will donate its one electron, right? So after donating its one electron, this 3 and 1 will not be there. So Na plus electronic configuration becomes 1s2, 2s2, 2p6. So is there any option matching with this? We have, yes, the second option is matching. So 1s2, 2s2, 2p6 is the right answer. So the next question we have is, which is acid salt? And the options are given as NaCl, Na2SO4, NaNO3 and NaHSO4. So acid salt is actually a salt which is formed by the action of strong acid plus weak base. Okay. So after the reaction of this acid and base, we'll have a neutralization reaction and then we have a acidic salt or acid salt. So now if we look at these options, wait, let's erase the tick marks. So now if we look at these options, we have NaCl, Na2SO4 and NaNO3 and NaHSO4. This NaCl, Na2SO4 and NaNO3, these three salts are actually formed by the reaction of strong acid and strong base. Like for example, let me tell you formation of NaCl. Okay. So in NaCl, we actually take HCl, which is a very strong acid actually. And with HCl, we take sodium hydroxide. Sodium hydroxide is also very strong base. So here we'll get NaCl plus water. Right? So here we are taking strong acid, strong base, we get NaCl. So NaCl cannot be a acid salt. But the same goes for Na2SO4 and NaNO3. But here in NaHSO4, which is sodium bisulfate, it is an acid salt which is formed by the neutralization of sulfuric acid. Okay. So neutralization reaction with sulfuric acid will give us a NaHSO4 because sulfuric acid H2SO4 is a very strong acid. So when we take this strong acid and we take any weak base of sodium, then it will give us a acid salt of NaHSO4. So now the 15th question we have, it is asking the general formula of cycloalkane is. Okay, and options we have CnH2n minus 2, CnH2n plus 2, CnHn and CnH2n. Actually, the general formula, CnH2n minus 2, it is for alkynes. Okay, alkynes general formula is CnH2n minus 2. Then the CnH2n plus 2 is actually the general formula for alkanes. The CnHn, this CnHn is actually the formula for cycloalkanes. Then we have CnH2n. The CnH2n is the general formula for alkenes. Okay. So now he is asking the general formula for cycloalkanes, right? So for cycloalkanes, the general formula is CnHn. So now 16th question here we have. The third transition metal ion is diamagnetic with the electronic configuration is. So if you want a transition metal to be diamagnetic or any element to be diamagnetic, it should have unpaired electrons. Okay, so any element to be diamagnetic, it should have unpaired electrons. And unpaired electrons in the transition series are present in the 3d10 series. Okay, so this 3d10 is there somewhere here. Yes, option number 4. So it should be 3d10. This transition metal ion will have diamagnetic nature also. Then next question. The main constituent of amalgam is. So amalgam, for example, you must have heard of sodium amalgam, right? It is nothing but a compound of sodium and mercury. So these amalgam compounds contain mercury as their major component. So the answer is mercury, Hg, option number 2. Now next, identify the correct matching. We have alloys and their uses. We have to match these. Okay, first we have is nichrome. So this nichrome wires are actually used in making heating devices, because nichrome wires do not get oxidized easily and they have very high heating capacity. They don't get hot very easily. So this nichrome can be used in making heating coils, right? So let's write down our matching order. First option should have C as an answer. Next we have is alnico. So this alnico is actually an alloy of aluminium, nickel and cobalt. So this alnico is actually used in making the artificial magnets. Okay. So this alnico can be matched with option A. Second option A. Then the third option automatically becomes option number B, right? Invar steel with measuring tape. Invar steel is actually used in making of measuring tape. So is there any option matching with our series? We have 1C, 2A and 3B. 1C, so third, fourth cannot be the answer. 2A, okay. And 3B, second option should be the right answer. Now next we have is, among the following index for the gold number is. So what is gold number? Gold number actually means the protective character. So a protective character of a colloid is a gold number. So is there any option which is matching with our protective character? So we have protective gold. Yes. So first option is the right answer. Protective gold, right? It is the protective character, gold number. Gold present in ornaments, extent of gold plating done, presence of electric charges on colloid. These are not the right options.